loops of material, plasma, very hot material that's jumping up from the sun's surface and down from the other part. That's following magnetic field lines. Something strange is going on with the magnetic field, and that's what we'll explore. So without any ado, let me introduce Matt Francis of Prescott Observatory. Good to have you here, Matt.
Thank you, Bob. I always enjoy these shows. I'm glad to be a part of this public awareness program.
Great. So again, as we look live here at this image, I'll tell you a little bit about SLU in a moment. Whenever anything exciting is happening, for example, yesterday we were talking about the new nova in the sky in the constellation Delphinus, which is brightening up and is already visible to the naked eye if you're in dark skies, and it's continuing to brighten. So who knows, maybe it'll even become bright from cities. We'll have to see what's happening. And there's often something exciting happening in the sky, but what's getting Earth's attention right now is the magnetic polarity of the sun. These are live images from Prescott Observatory Solar Telescope of the sun changing its orientation. Let's look at a little graphic showing that. First of all, this is from a NASA-produced graphic showing how the field of the sun goes from north up to south up, and when that happens, everything that's north or above the equator of the sun, which used to be one general polarity, has changed to the other. And what also happens within that are sunspot groups reverse their polarity, so that within a spot where usually as the sun is rotating, you can see that sunspot on the left, by the way, in this live image from Prescott Observatory. See that storm? Well, often they come in twos or threes, and the leading spot as the sun rotates, sun takes about a month to make one spin, the leading spot is one polarity, positive or negative, and the trailing spot behind it is the other polarity. And then in the opposite hemisphere of the sun, that's reversed. What else are we seeing here? Matt, what are we looking at?
So we're looking at the eastern limb of the sun. So the sunspots that we see, the one to the left, is coming into view, and in the next week will be directly facing Earth. And we also see the lighter areas, the faculae, where magnetic currents are weaving their way in and out of the canyons created by the granules on the photosphere.
It's fascinating. Faculae is a word from the Latin meaning little torches, because early observers like Galileo thought that it was almost as if someone were carrying around little torches on the sun. Of course, the sun is one giant torch, that's for sure. Back then, they could not figure out what is making the sun shine. If it were entirely a lump of coal, it's been calculated that it would burn itself out in just 2,000 years. And once we knew that Earth is a lot older than that, and the sun is a lot older than that, we had to go back to the drawing board. And it wasn't until 1920 that Arthur Eddington, the British astronomer, figured out that it is a nuclear process, that the sun in its core is converting hydrogen to helium, and in doing so it's converting mass to energy, just the way Einstein had said shortly before that in his 1905 and 1915 theories, that the sun actually changes bits of its body into energy, and in the process loses 4 million tons of itself every second. Meaning that if you weighed the sun, if you had a giant scale, the sun actually weighs 4 million tons less every second. It's pretty amazing. So our live image from Prescott Observatory. Let's show you another picture, a color image, while Matt repositions the telescope. Oh, look at this. Look what we're looking at now. My goodness. Matt, you want to tell us about it at your telescope?
Sure. This is currently the largest sunspot visible to us right now. So you can see there's I think you can see exactly what you were talking about, Bob. There's actually a pair of sunspots. There's the large one on the right, and then there's faculae in the middle, and there on the left, a much smaller, dimmer sunspot of opposite polarity.
Now, of course, we can't see magnetism, magnetic polarity, but if we could, we'd see that if it were a magnet and we dropped iron filings on it, it almost looks like that's what we're looking at. You'd see that one spot is positive, the other is negative. But above the equator of the sun, the polarity is opposite. Well, that is what is flipping. The whole general magnetic field of the sun and all the polarities of the sunspot groups are also changing. Now, it doesn't happen at a particular moment. You can't say, for example, that at 1:57 Eastern time on a certain day, the magnetic field goes flip. What instead happens is that once the process begins, it becomes almost a sporadic thing where areas flip, the general field gets a little chaotic, and then the whole thing reverses itself. As we look at these fabulous views, seeing the granules on the sun, those bright faculae, the bright areas, the black sunspots, which are actually not black at all. If you could see them isolated, if you could see that black sunset, a spot against the darkness of space in the night sky, you wouldn't even be able to look at it. It's actually almost as bright as the sun itself, but a slightly less brilliant area seen next to a brilliant area will look black. That's just this is just how it goes. The reason so is it's a little cooler than the rest of the sun. Not cooler in the hip sense, but in the temperature sense. And that's because the magnetic field there, just locally, is up to 5,000 times stronger than in the surrounding areas. So that material welling up from below in the hotter regions of the sun are being squeezed and slowed down. Slower means cooler, and that's why we get these black sunspots. They're really centers of intense magnetic activity, storms in a way on the sun, and the number of sunspots correlates with the amount of activity that the sun has, and this affects Earth.
You know, Bob, you were mentioning, speaking of storms around the sunspots, and you were mentioning the difficulty in predicting such things. And I was reading recently in your book, The Sun's Heartbeat, about the Maunder minimum and the Carrington event, and it made me feel like it's very hard to predict solar activity and what's really going to happen.
Yes, especially with those that you've just mentioned, and the Maunder minimum for an entire human lifetime from 1645 to 1715, the sun's cycle of spots just stopped cold. The heartbeat just stopped for a whole, we're talking about 75 years, and no spots were observed on the sun, and the magnetic field of the sun seemed to almost wither away, and it was the most startling thing. It affected Earth. It made Earth cooler. The canals of Venice froze solid. There were icebergs around the English Channel. It was a time of great hardship around the world. We had the coldest winters we've ever had in the colonies in America at that time. So the sun definitely affects the Earth, and speaking of that, we have a great interest in the field on Earth flipping over and changing polarity. And that's because Earth's magnetic field also changes. It's been 780,000 years since there was a change. On the sun, as we watch these clouds roll by the way, this is pretty dramatic, these live images of the sun, even though the sun is momentarily covered up, it still looks pretty dramatic. Here on the Earth, about 3 times per million years on average, our poles flip. Now, it's been 780,000 years, so we're quote-unquote overdue, but these magnetic polarity reversals, each one of them is called a chron, and a chron can last for as little as 50,000 years or as long as about 50 million years. So they're irregular also, and we've known of over 100 pole magnetic polarity flips on the Earth throughout history. Easy to tell them because when lava or magma comes up from volcanoes, when the rocks are still molten and they contain any metal, as soon as it cools to what's called its Curie temperature of 1414 degrees Fahrenheit, as soon as that happens, all the iron in the rocks align with Earth's magnetic field. So by digging down and checking out the alignment of these little iron particles in rocks as you look through the geological record, we can see how Earth's magnetic field was going through history. And here's the good news. When our poles flip, it does not affect the life on Earth, meaning that these times of earthly pole flips, which, by the way, can take do take thousands of years, so it's nothing that happens overnight while you're having a latte or something. This happens very, very slowly. And when they do happen, there have never been mass extinctions or new life forms dying out and new ones coming in. So it's quite clear that when the earthly poles flip, it does not harm us. In fact, the new thinking is that we always have some kind of magnetic field, even if the general poles aren't there the way they did. Temporary poles are set up, and they kind of flicker back and forth, but nothing bad happens. And nothing bad happens with the sun either, because this happens every 11 years on average. The current one is really odd because we've just finished the oddest sunspot cycle in the life of anybody now alive. Instead of 11 years, it's taken 14. The sunspot minimum in 2006, 7, 8, and 9 was so low, so deep, that nobody, again, alive has ever seen such a deep, total absence of spots. And because of this, some think, that's why global warming has not proceeded the way logic tells us it should have. In other words, temperatures wide have plateaued, and so the sun really does affect us. What are we looking at now, Matt?
Actually, we're looking at a cloud. The cloud has moved. Oh, I'm sorry. We're looking at, I see you have the sunspot up, Pat. Yeah, so this is, again, that largest sunspot that I was showing live a few minutes ago before a giant cloud slid in front of the sun. And the reason this is color is because if you were to look through my telescope with an eyepiece, you would be looking through a special filter, a hydrogen alpha filter, and this is the color that it would appear through an eyepiece. So, that's because of the filter. Now, if you were to fly to the sun, of course, you would see it as it looks in the live view, which is just finally emerging out of the sun, thank goodness. And it would be white as it emits all the full spectrum.
That's right. So the sun, although some people think of the sun as a yellow star or an orange star, it's actually a pure white star. That's what astronauts report, and high-altitude balloonists. The yellowish color, the lemony color of the sun that we ground dwellers perceive is just an artifact of our own atmosphere, which removes some of the blue light from the incoming sunlight to give us our blue sky. We like our blue sky, but we didn't get the blue sky for free. That blue light scattered out of the incoming sunlight, leaving behind a sun that looks yellower from the Earth than it really is from space. I want to mention also that if you want to more views, not just of the sun, but of the amazing things we see, check out the on slew.com. You'll see the community where people are discussing, and we have Slew conversations where members are talking about the stuff we're seeing. You can always go to the free iPad app, Slew's iPad app, just download it for free, and you can control the telescopes, or even check out a Slew membership where you can indeed control these telescopes and point it anywhere you want in the whole universe when you want, and have amazing full color views of Jupiter or galaxies, use them as screensavers or whatever. So that's what we do. These are fabulous images, getting back to what we're looking at now, fabulous images of the sun that we've been bringing you live with Matt Francis and Prescott Observatory here at the Slew Space Camera. These are pretty amazing. The sun has gone behind a cloud just temporarily. Oh, and there it is. It's come back. We're looking at live views of an interesting corner of the sun, and seeing an overhead view of not just the granulation on the sun, a major storm that's in Delphinus, which is brightening up and is already visible to the naked eye if you're in dark skies, and it's continuing to brighten. So who knows? Maybe it'll even become bright from cities. We'll have to see what's happening. And there's often something exciting happening in the sky, but what's getting Earth's attention right now is the magnetic polarity of the sun. These are live images from Prescott Observatory Solar Telescope of the sun changing its orientation. Let's look at a little graphic showing loops of material, plasma, very hot material that's jumping up from the sun's surface and down from the other part. That's following magnetic field lines. Something strange is going on with the magnetic field, and that's what we'll explore. Live here at this image, I'll tell you a little bit about SLU in a moment. Whenever anything exciting is happening, for example, yesterday we were talking about the new nova in the sky in the constellation. So without any ado, let me introduce Matt Francis of Prescott Observatory. Good to have you here, Matt.
Thank you, Bob. I always enjoy these shows. I'm glad to be a part of this public awareness program.
Great. So again, as we look